Hello Professor, my name is Nehal Vaishnav and I am the group member of group number 1. This is our project Motor Vehicle Collision. This is the team. Nehal Vaishnav, I am the team leader. Anuj Rathod is the data analyst and Siddharth Trivedi is the developer. So this is the implementation plan. Right now we are on the testing phase, as you can see here, 14th July to 28th July, and the whole team is the part of the testing phase. So tools and techniques that we use for the project. We started by having the regular team meetings to to track the progress and take the notes during meetings and to store all the documents and everything, and also to make sure that everyone is on the same page. The SharePoint to track the progress, minutes of meeting, timesheets and project documents, and this SharePoint helped us a lot to keep us updated in everything. Weekly meeting with client. We made sure that to keep our client informed by having weekly meetings with them. This way we could update them, and also we can get the feedbacks on how we are doing and how we are going on in the project. Then comes the Power BI. This helped us a lot to perform the visualization and creating an interactive dashboard that we will show you in the further slides. Here are some of the challenges that we faced. Challenge 1, it was a data set. The data set that we chose was very large and it was quite challenging to clean and everything. So but by performing the cleaning and coding process and the EDA process, we handled it. By handling some of the outliers and everything, we did it. Second was the SharePoint. It was very much new to us. We haven't done anything with it. So initially it was a bit challenging for us with the functionalities and working of it. But together as a team, we saw a few videos and all the documentation and read some of the documentation to understand how the process does. So this is my technical part. This is the data cleaning that I have done. First I will show you the screenshots and then I will show you the working part of it. This is the second screenshot, third one and fourth. So this is the coding, this is the cleaning part that I have done. First I imported the data set and then it will show us how many columns and rows are there. So we have this many rows and 25 columns, so it is quite a big data set to deal with. Then we did the half of it to perform the better analysis. This is the data dictionary, that which column has which data type. So there are 25 columns in total, and this shows the data types. Also this shows how many null entries it has. So this 4 has 0 null entries, so and rest of them has so many null entries. So further we will go. So we replace the null entries by this. So this is the coding that I have done? Yes, Professor. So that's it by my side. Now Siddharth will further take over.
Hello, Professor. My name is Siddharth Trivedi. I am a group member of group number 1, and I'm here to demonstrate my part of project. So here is some snippets I have attached in the PPT. So this is the visualization of like heat map I have done based on the clean data set as Nehal discussed. These are just like some snippets. This is the of k-means clustering snippet, and that model I have applied to the data set. I'll demonstrate it further in live, but this is the snippets, and also the ARIMA I have performed. So yeah, as Nehal discussed, she did cleaning of dataset with the coding, and she cleared out the null entries with the replace of mode values, and all the columns are ready to apply the models, so I can train them. So here first I check the relationship between the columns, and I have used here vehicle year and vehicle occupants. So like I'm just checking the correlation between them, so I used a heat map to do that. Then I also like I have done some uh, labels encoding, like just have to clear the numbers to an object, and then I created k-means clustering of two different variables into two visualizations. So here is the vehicle type and strategization k-means clustering visualization graph, and here is a pre-crash and vehicle damage graph. So here you can see that chart is quite very uh, lot of objects, so it's not does not make sense any here, because we have a lot of data in the data set, and this is also does not make sense because it not representing anything. And based on that I have some done some predictive analysis. So here is the code of that. So first I have checked the vehicle types and how many types I have, how many cars uh, got collisions in that, and then like I have done three model. I have trained data set and applied to three different models, so I can check how much accuracy I am getting it, because we have done the data set manually, because the price insurance price is not fixed, and we have did manually by increasing the value after every collisions of the same car. So I'm just checking it that my code is working properly or not. So that's why I have applied the support vector regression. Here is the snippet of that. First here is the training model, the snippets of train model that I have done. Here is the, and I have like taken the 10,000 entries, but in that I have trained that 7,500 entries into the train model, and rest of the 2,500 for test. So here's the snippets, and this is this SVR model I have applied, and I am getting 53% accuracy in that. So just to be clear myself, I have used another analysis, and luckily I got 99% accuracy in that. But this is not fixed, this is just based on that previous data, but might in the future the accuracy will be changed. And then I have applied time series data ARIMA model. So here is the code of that I have applied. Here's the time series data, and this is the ACF auto correlation function, which is like measure relationship between point and lagged values while controlling the influence of uh, the data and intermediate that lags. And under that, this is a PACF, like this represent the drop values from 1 to 0, and that Here is also this both are very important in the ARIMA time series forecasting. And here if he is forecasting, let these 5 values are forecasted in the few next 5 collisions. If happens, what will be the insurance price, so we can give them the price. And this is the chart of ARIMA forecasting. So this is all from my side. Now Anuj will take over.
Hello, Professor. I'm Anuj Rathod. So, this is the final part of the presentation. I'm the group member of Group 1. So, I'll be discussing the technical part from my side. So, here is the dashboard cover page for the motor vehicle collisions. And here are the visuals that I have created for it, and the further different visuals using the slicer filter. And I'll be showing you so these are just the snippets, so I'll be showing you the live dashboards. So here's the cover page, and here I can directly go to the dashboard by clicking onto it, and here I am. So in this visualization, when I was doing it, I figured out a lot of things by creating different visuals. I got to know about each car make that has the highest number of damaged vehicles by type. So in this visual we can easily see that sedan has the highest number of damaged vehicles. After that it comes the sport vehicles, and following it there are like the different type of vehicles like motorcycle, ambulance, car, truck, bus, etc. So this is one of the important aspect for the insurance companies, that they can target the sedan cars and the sports cars highest, because those cars get involved in the collisions frequently and in highest quantity. So that is one of the important aspect. And also this can be considered as a point that the drivers who are parties like getting involved in the collisions, highest number of those are licensed, and they have to be licensed so they can claim the insurance or get into it. If they are unlicensed drivers, then it becomes illegal for them. So it is pretty evident that the highest number of vehicles that are collided, the drivers were licensed. And also one more analysis that I found during the visualization was that the number of crashes by car makes. So like for particular cars, what is the number of crashes? So it was seen that Toyota car, the Toyota SUV car had highest number of collisions. Honda SUV car had the second most, and further following all of it. So insurance company can also, like insurance company, you should also focus on the car companies, that which company is making the car, whether it is SUV, sedan, or a two-seater motorcycle, anything. So this is one of the important aspect, because there are chances of the specific company which makes really good cars, or it doesn't have any like technical problems in it, so the chances of collision decreases. But in here it can be seen that the Toyota car has this many, like 0.3 million crashes. So they can target these companies and increase the insurance claim price or the insurance plan, something like that, so they can pitch them directly. And also I have added a slicer filter in here, because it has all the states of USA. So it can show the data of each state, so and each state and of each year, like from 2016 to 2021. So you can see for like different states the visualization is changing and stuff. So this helps to make it more clear, more easier. This is the visualization of NY, New York. So this is how the visualization I have created, Professor. And this is the SharePoint link. I'll just go through it quickly. The dashboard page, and here's the minutes of meeting. I added the last meeting with the client, the feedback that we got, the budgeted hours, and the team members involved, the next meeting. And also I added the action items. And also in this we are like at the almost at the final stage in here. In the MRP high level task, the timeline is also fixed, and it has all the data in it. And the recent testing phase, and the dashboard analysis is here. So currently we were at dashboard analysis testing phase and the timesheets. So everything has been added, and here's the SharePoint. So thank you so much, Prof.